Hello friends, I'm Jaideep Deshpande and I welcome you back to my channel. Today we are going to analyze a plate which has symmetric features in ANSYS mechanical APDL. We have a square plate of 500 mm length and we have a 200 mm diameter drill at exact center of the plate. We are applying a 1000 Newton compressive force on both the sides, and now we are going to analyze this system in ANSYS. The problem in this case would be the computation time would be more if you analyze the entire plate, and it will get reduced by 1/4 if you just analyze the quarter that I've marked over here. So we are going to break down the entire plate into a quarter and then expand the quarter to obtain the results for the plate. So let's begin. We'll start with usual picking up the element. So for this we are going to use plane element which can be found in solid. So first is quad 4 node 182, that element we are going to use. This element does not require any real constant, so we are going to skip this step and move to materials. The material is steel, so go to steel, linear, elastic, isotropic. We are going to follow our regular Newton second system. So the value of Poisson's 0.3 and Young's modulus is inserted and close this window. In this case, we are going to create areas and then mesh the areas to obtain nodes and elements. So first we'll begin with creating the first quarter or the right quarter of the plate. So go to areas, rectangle, by dimensions. So the bottom corner is going to be origin. So first coordinate is 0, 0 and the next coordinate is 250, 250. So that will create the quarter. To create the hole, we are first going to create a solid hole and then subtract it. So to create a solid hole, go to circle, solid circle. It is at the origin as the center and with a radius of 100 mm. So click OK, you have it over here. Now to create the hole, we are going to subtract the circle from this area or the square. So to do that, go to operate, go to booleans, go to subtract areas. From this area you have to subtract this area. So click on OK and you have the quarter ready with you. Now we'll go and mesh this. To mesh this, first we'll have to see what mesh would look good. The mesh has to originate from this curve, since we are going to fix this curve, and it has to uniformly pass to these two edges. We don't want any of the mesh going from this bottom edge to this vertical edge, since these are going to be the symmetrical edges. So to do that, first we'll have to concatenate these two lines. So the mesh will originate from this curve and merge into these two edges. Now we'll mesh it, go to mesh tool. Since we have mapped it, go to mapped and click on mesh, click on area and click on OK. So it will mesh it. The mesh is not so good. To make the mesh more good, go to refine at nodes, refine, and here you have to pick all. So here you can select the intensity. I'll go with 2 and click on OK. So now I have a nice mesh over here. So now let's move on to the boundary conditions. Go to loads, define loads, apply, and first we'll go with displacements. We'll first fix this curve. So we'll begin with picking on lines. We'll pick this line, click OK, and we'll fix it with setting 0 value for all degrees of freedom. Here one important point we have to notice that the vertical edge and the horizontal bottom edge, we have to have a symmetry with respect to these two edges. So how we are going to do that? So to do that, we have an option over here of symmetry boundary condition, symmetry BC. So go to that and select on lines, select these two lines and click on OK. As soon as you do that, you can notice one S appearing over here, which tells you that symmetric condition has been applied. Now we'll apply the force. To apply the force, click on nodes. To apply the force on entire edge or entire length, we have to select box over here. Start with this, say this point, and drag your mouse down. So it will select all the nodes in that box and click on OK. The value is 1000 Newton compressive, so we have to add a minus sign over here and click on OK. So our force is applied, our system is ready to be solved. Now go to solution, solve, current load step, and click on OK. Our solution is done. So before we actually see the results, first let's expand the geometry. To expand the geometry, go to plot controls, go to style, go to symmetry expansion, and you have to select the first option, that is periodic or cyclic symmetry. Since we have drawn the quarter, select the first option and click on OK. So now here you can see the entire plate. Now let's view the results. Go to post processing, go to plot results, to contour plot, nodal solution, and we'll view say displacement vector sum. Click on OK. So here you have the results. If you forget to set the symmetry boundary condition, you are going to observe a tearing along this edge, and you are going to see some overlap along this vertical edge. So it is at most necessary to break down your entire geometry into symmetric equal parts and then expand the symmetry by applying the symmetric boundary condition and geometry expansion. If you have any doubts, feel free to ask. You can post the comments down, or you can visit my blog for more details and comments. Thanks a lot for watching my channel. If you haven't followed my channel, go to YouTube and follow. Thanks.